Hello, and welcome to Ray's amazing math class. Today we are presented with a situation. Grace makes an investment in a local company after she graduates from university. This company has seen tremendous growth. Grace plans on holding on to the investment for several years until it reaches $500,000. At that point, she will use the money to open a small bakery that she has always dreamed about. We are told that after 4 years, Grace's investment will be worth $160,000, $160,498.97. And after 8 years, Grace's investment will be worth $252,548.24. We have to find the rule, graph, and table for Grace's investment. So, I've already made one for myself here, the graph, table, and rule, but I'm going to make one from scratch. So, since we're presented with 2 points, we're going to put that into a table. So, for $160,498.97, and after 8 years, it will be 252,548.24. So we have 2 points here. But our first goal is to find the common ratio for each consecutive year. In order to find this, we're going to find the radical symbol right here. Why we need this is because this n is going to represent how many years have passed, and this representing how much it multiplied. So we're gonna put 4 because 4 years have passed, and 252,548.24 divided by 160,498.97. We can see that B is going to be around B, or the common ratio is going to be around 1.12. And since it is 1.12, which is greater than 1, we can see that this is going to be a form of exponential growth and not decay. And we're going to put a variable for this, which is going to be B, which is going to represent the common ratio in our question. We're going to put f of x for our function notation equals, and in order to find the initial value, we're going to move backwards from $160,498.97 by dividing this to the fourth power, since that will give us the value of y when x is going to be 0. So $160,498.97 divided by b to the fourth power. That's going to be the initial value, and since we found the common ratio earlier, we're going to just put b here to the x power to represent how many years have passed since the initial value. So we have a rule now, and we just got to fill out the table. However, since we also use function notation here, we're going to replace this with f of x of 1. So 9 to Okay, I'm gonna fill the middle parts out so it doesn't get confused. We're gonna fill it out all the way to 15. Now we have a table, rule. But where's the graph? Table and rule. But where's the graph? So we're gonna zoom out over here. And it's all the way here. So let's frame the graph. For the x-axis, we're not gonna need more than -2, and for this we're not gonna need more than 15. And for the y-axis, we want to see when the graph is going to get to 500,000, and if the graph is going to do that. So we're going to put $550,000, and for the y-axis, for the negative part, we're going to put -20,000. Now the graph is shooting in the middle of the screen, but we need to restrict the domain here. So we're gonna put these big parentheses, and x is greater than or equal to 0. The graph is starting all the way over here, and we will not get confused. Now we have to see when her graph is going to cross $500,000. For me, a simple way to do it is by creating a line that goes through the value of y equals $500,000, so we can see exactly where the graph intersects $500,000. It says 14.027, which is approximately going to be about 14 years. Now, these 14 years show us that after 14 years, after she put in her investment, she'll gain $500,000. Her investment will be worth $500,000, and she'll be able to open the bakery shop that she wanted to. Thank you.